Okay, so in this video, we are going to be looking at the combinatorics of poker. Okay, so there are many different varieties of poker. It's a card game, but there are many different variations. And we're going to consider in this video probably the simplest. So we're going to consider what's known as just straight poker. And what is that? That is where each player is just dealt a 5-card hand from just the standard 52-card deck. Okay, so you sit down to play. You get a subset of 5 cards. That's your 5-card hand from the deck, and that's your hand. Okay, so those are the cards you have. And the way the game is played is there are certain categories that hands can fall into based on the cards in them. And these categories are ranked. And some of these types of hands beat other types of hands. So if you end up with a hand that beats everyone else's hand, you win. So if there was money that was bet, you would win all that money. Okay, so that's how this poker game is played. So what we want to do is look at all of those different categories of different hands you could have, and we're going to actually count. Okay, so combinatorics, it's like a fancy way of just saying counting. We're going to count how many possibilities there are for hands in each of these categories. Okay, so let's find how many 5-card hands fall into each of the following categories. Okay, and some of these categories might be familiar to you. If you've ever played poker, of course, you'll know all of them. But if you haven't, maybe some of them will make immediate sense and some I'll explain as we go along. Okay, so I'm just going to list them all here, and then we'll get into the counting after. Okay, so there's something called a royal flush. There's something called a straight flush. And by the way, one more thing I have to mention. Some of these categories are actually sort of nested in each other. So it turns out a royal flush actually is a certain type of straight flush. Okay, but when we're counting, we want to kind of be counting how many of each distinct type of hand you could have. And of course, in poker, you want to have the highest ranking hand possible. So why would you call your hand a straight flush if it's actually a royal flush and that's ranked higher? Okay, so for each of these categories I'm listing here, we're going to assume that any hand that falls into them, okay, that is the highest ranking description of that hand. So when I say we're going to count straight flushes, I mean it's hands that are just straight flushes. They're not actually a royal flush, which is a type of straight flush, but more higher ranking. So I'll even make a note here. This is excluding royal flush. Okay, and when we get into counting all of them, I'll put descriptions for each type of hand, so we'll know exactly what we want to count. Then there's 4 of a kind. That one's pretty self-explanatory. You have 4 cards in your 5-card hand that all have the same value. Of course, you can't have 5 cards with the same value because there's only 4 suits in a standard deck. Okay, the next one is a full house. Full house. Okay, that's where you have 3 of one value card, so like an ace of clubs, ace of diamonds, ace of spades, and your other 2 cards are a pair. Okay, so maybe what I just said would go with maybe queen of hearts and queen of diamonds. So that 5-card hand would be a full house. Then there's something called a flush. Okay, a flush just on its own. A flush is just where you have 5 cards all of the same suit. Okay, so obviously a flush is not necessarily a straight flush, right? A straight flush, it's going to turn out as a flush where all of the values of the cards are in increasing order, or they're consecutive. Okay, so like 2, 3, 4, 5, 6. Right? If you had those 5 value cards all of the same suit, that would be a straight flush, but you could have a flush that's not a straight. Right? That would be just 5 cards of the same suit that aren't sequential. Okay, so I'll write here, this is excluding the royal flush and the straight flush. So all of these excluding things It's just what I said before. Okay, we're just going to call a certain hand falls in a certain category if that is the best description, the highest ranking description of that hand. Okay, so if we count a hand that's a flush, that wouldn't be a straight flush because straight flush is more higher ranking. I'm listing all of these in order of ranking, by the way. Okay, the next one is just a straight. Okay, and this is excluding the royal flush, which is also a straight, and the straight flush, which is also a straight, obviously. Okay, and then we have 3 of a kind. That's pretty self-explanatory. 3 cards of the same suit, but in particular not 4, right? Because then it would be 4 of a kind. And then we have 2 pair, so 2 sets of 2 cards that have the same value. Then we have 1 pair. And then if you have none of the above, some people call this no pair, or some people also just call this high card. Essentially, in this game of poker, if you don't have any of these categories above, then your hand is just based on the highest value card you have. Okay, so if there was someone else who also had nothing, their hand didn't fall in any of the other categories, the person who wins is just the one who has the highest value card. Okay, so these are all the hands, and they're listed here in order of ranking, so any hand listed above any other beats the one below. And if you think about it, right, this is a game of chance. It depends on which hand you get when you're playing. So if it were the case that a hand that was more likely for you to get beats a hand that's less likely to get, that doesn't really make sense, right? We want the rarer hand, the hand that's more unlikely. In some sense, that's, more rare. It's more special. That should beat other hands that are more common. And that's what we're actually going to see as we're counting. We're going to see that as we go down this list, the number of hands that fall into each category increases. Okay, so the hands that rank the highest, that beat other hands, are the ones that are the most rare. All right, so that's our game plan. I'm going to describe in more detail what each of these categories really is. And then we're going to count using, combinatorial techniques. This will be good practice if you've just recently learned about, N choose K and permutations, combinations, stuff like that. So it'll be really good practice to go through and calculate how many 5-card hands there are in each category. All right, so without further ado, let's get into the royal flush. Okay, so what's a royal flush? Well, it's a flush, meaning all the cards have the same suit. Okay, and it's also a straight, meaning all the cards are sequential in order. Okay, but it's a particular straight flush. It's one where it's all of the highest value cards. Okay, so this is going to be 10, Jack, Queen, King, and Ace, all of the same suit. Okay, so that's a royal flush. By the way, when I keep saying sequential value cards, so all the cards listed in order are Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. But you might be saying, hey, wait a second, Ace is on the left here. Here you put it to the right of the King. And it turns out that for straights, an ace can either be the lowest card or the highest card. Okay, so if I'm talking about sequential cards, this would be the order, but it can't be both. So for instance, Queen, King, Ace, 2, 3, that would not be 5 cards in sequential order because the ace here is playing the role as a high card and a low card. Okay, so this, in other words, it doesn't wrap around. Okay, but for instance, this would be a straight, that would be 5 sequential cards. Okay, this would be a straight, that's also 5 sequential cards. There, ace is playing the role of the smallest value, and of course anything in between. Okay, so when we get to counting straights, this will play more of a role, but I just wanted to write that here in case you were wondering why the ace was to the right of the King. It's because the ace can be the low card or the high card in the straight. Okay, so the royal flush is those 5 cards, all the same suit. Okay, so how many possible 5-card hands are there that fall in this category? Well, what choices do we have? We don't have a choice about the values of the cards. They have to be those 5 values. The only thing we have a choice about is the suit. Okay, so there are just 4 hands simply because there are 4 suits. So what would those four royal flush hands be? Okay, it would just be the 10, Jack, Queen, King, and Ace of clubs, and then the same thing of spades, of diamonds, and of hearts. Okay, so those are the 4 hands. And on the side here, I'm going to, as we go through counting, okay, I'm also going to write the percentage of all the hands that fall into this category, because the percentage is going to give you a probability, right? If I just dealt you a 5-card hand at random, all of the 5-card hands would be equally likely. So how would we get the probability you get a royal flush? We would just say, oh, that's 4 hands out of the total number of hands. What is the total number of hands? Well, you're getting a subset of 5 cards out of the 52 cards. So there are a total of 52 choose 5-card hands. 4 of them are royal flushes. So if we wanted the probability of getting a royal flush, it would just be 4 divided by 52 choose 5. Okay, so that is the percentage of 5-card hands that are royal flushes, but it's also the probability that you would get a royal flush if I dealt you a 5-card hand at random from the deck. Okay, so that's the percentage and probability I'm going to write, and for royal flushes, it's pretty small. We have 3 zeros and then 154%. Okay, so this is the most rare type of hand you could get. Okay, and you're very unlikely to get it, obviously, because 52 choose 5 is a big number. So 4 divided by it is a really small number. Okay, so the next type of hand is a straight flush. What's a straight flush? Okay, and again, we're excluding the royal flush, because otherwise we would call this hand a royal flush. Okay, so we're excluding that one. And this, the description of this hand is it's 5 sequential cards. I already talked about what it meant to be sequential. 5 sequential cards. Okay, and remember the ace can be a low card or a high card, but not both. Okay, and it's 5 sequential cards of the same suit. Okay, so the straight has to do with the 5 sequential cards, and the flush is all the same suit. So how many are there? Well, let's deal with the values first. For a lot of these questions, it's good to think about the values the cards can have and then think about the suits. Okay, so what are the values the cards could have? Well, we could have ace, 2, 3, 4, 5. Okay, we could have 2, 3, 4, 5, 6. We could have 3, 4, 5, 6, 7, ... all the way up to 9, 10, jack, queen, king, and finally 10, jack, queen, king, ace. Because remember, ace can be low or high. It's just like we have a little sliding window here of length 5, and we shift it along. How many different windows of length 5 do we have? Well, there's the first one, there's the last one. You can see here there are 10 starting positions for that sliding window. Okay, so there are 5 possibilities for the values of our straight flush here, or just a straight in general. Or sorry, I think I just said 5. 10 possible values for our straight here. Okay, in terms of the values. 5 sequential cards, there are 10 options. Here's a list, but remember, we don't want to include this last one, because if we have these values and it's a flush, meaning they're all the same suit, that would be a royal flush. So we really just want to include these. You can see, based on the starting card, you can think of ace maybe as 1. There are 9 different options here. So there are 9 options for the values of our cards. So I'll write that down. So there are 9 options for the values. Value options for the 5 cards. Okay, we just listed them. What about the suits? Well, we're fine with any suit for this card as long as the 5 cards have the same suit. Okay, so for each one of these value choices, we have 4 choices for which suit, right? It could be those 5 cards of hearts, those 5 cards of clubs, and so on. So we get these 9 options, but for each of those 9 options, there are 4 options for the suit. So that's 9 times 4. Okay, so this is the suit. And we get 36. So there are 36 hands. What percentage is that? Well, it's 0.00139%. Okay, so also very unlikely to get a straight flush. That's pretty rare as well. Okay, just to give me some more space, I'll start on the next page. So 4 of a kind, that's the next highest hand. Okay, and like I said before, definitely keep track. These different categories are going to get more and more common, and that makes sense why we rank them in this order. We want the rarest categories to be the highest ranking. So 4 of a kind, pretty self-explanatory. It's just 4 cards of the same suit. Okay, 4 cards of the same suit. So if we draw a little circle here, this is sort of maybe thinking of our hand. And remember, a 5-card hand, we don't care what order the cards are in. We just care about the set of 5 cards we have. So that's why I draw it in the circle. It's just going to be, kind of these slots for cards that are just somewhere in the circle. We don't care about any order for them. Okay, and so maybe I have the ace of hearts, I have the ace of diamonds, the ace of spades, and the ace of clubs, right? Maybe these are my 4 cards that are all the same value. That would give me a 4 of a kind. And then I have 1 card left over. Okay, I have 1 card left over. So how many different types of hands are there? How many hands fall into this category? Well, what choices do I have, right? The kind of choices, the degrees of freedom are what's helping us count these hands here. So let's focus on the 4 cards of the same value. Well, if I'm going to have 4 of a kind, they have to be 4 of some value. How many different values are there? There's 13, ace through king. So there's 13 different values that my 4 of a kind could have. Okay, and that's it. I don't have any choice about the suit. I have to have all 4 suits in there. Okay, so the suits are determined. Okay, it's as soon as you tell me the value, like ace, I know what 4 cards there are. I have no more choice about the suit. Okay, but what I do have choice of is this last card. Okay, so how many remaining cards are there that would give me choices for that last 5th card in my hand? Okay, well, I've already taken up 4 of the cards to be in my 4 of a kind. Okay, so how many other cards are there that could fall into that 5th spot? Well, there's 48. Right, 52 card deck minus those 4 is 48. This is the number of remaining cards. Okay, so for any value you give me, maybe ace, these 4 cards are determined by that value. And then for any such choice of the 4 of a kind, I have 48 remaining cards that could fall in that last slot there for my 5th card. Okay, so for each of these values, there are 48 options for the 5th card, so I can multiply them, right? That's what multiplying does. For each of the values, there are 48 options, so how many total options are there? Well, there's 13 values. Each one has 48 options. You multiply. And what do? You get 624. Okay, and this is 0.024%. Okay. By the way, I mean, this is percent, right? So 100% would be everything. So we're 0.024%. This is still very, very rare type of hand. All right, the next one is the full house. What's a full house? Well, it's 3 cards of one value, okay, and 2 cards of another value. Obviously, we know those 2 values can't be the same because that would be 5 cards of the same value. That's not possible. There are only 4 suits. Okay, so this one's a little interesting. So I'll draw my little circle for my hand, and we're going to have a set of 3 that all have the same value, maybe ace of diamonds, ace of hearts, ace of spades. Okay, so those are my 3 cards of one value, and then I have another 2 cards of some other value. I don't know, maybe jack of diamonds and jack of clubs. Okay, so those would be my 2 cards of some other value. So this would be an example of a full house. So how do we count how many full houses there are? Okay, well, you see we have 2 different values in play. All right, so again, I'm going to break this up into thinking about the possible value combinations and then the possible suit combinations. So let's think first about the choices for values. Okay, how many choices of values are there? Well, every full house can be described by 2 values, right? I could have in my first slot the value for my set of 3, and the second slot my value for the set of 2. And we already said those 2 values are definitely different, because otherwise I'd be saying there are 5 cards that have the same value, and again, that's not possible. Okay, so how many choices do I have for the values? Well, for the set of 3, I can say, all right, there's 13 different options, ace through king. Now for the set of 2, I've already used up one of my options for the set of 3, right? These 2 options for values have to be different. So there's only 12 remaining. So for each choice of my value for the set of 3, I have 12 choices for my value for the set of 2, so I can multiply. Okay, this is similar thinking as to when we talked about permutations in a previous video. Okay, so there are 13 times 12 different choices for the values, but now I have to worry about the suits. Okay, so for each value pair, right, for example, like, ace jack, right, that's the example in the photo. Okay, so for each value pair, what are our choices for the suits? Okay, well, for the first value, I get to choose exactly 3 out of the 4 suits for my cards. All right, I get to choose exactly 3 out of the 4 suits. Here, it's diamonds, hearts, and spades, but you can imagine the same hand here, where instead we have, hearts, clubs, and spades, right? Okay, so I get to choose 3 out of the 4 suits, and that's just a subset of 3 out of a set of size 4. 3 out of 4 suits, that's 4 choose 3. So that's how many choices we have for suits in the set of 3. And how about choices of suits in the set of 2? Well, there's still 4 suits, but now I have to choose a subset of 2 of them. Right, so that's 4 choose 2. Okay, 4 choose 2. As soon as I specify the card's value, say jack, and the subset of 2 suits there are, I have specified this part of my hand. Okay, so that's 4 choose 2 choices for suits in the set of 2. Okay, so what's my final answer here? Well, I have all of my value choices, that was 13 times 12, and then for each value pair, I have an additional 4 choose 3 choices for the suits for the set of 3, and on top of that, an additional 4 choose 2 choices for the suits of the set of 2. So what does this equal? Well, this is just 13 times 12, 4 choose 3. Okay, that's just the same as 4 choose 1. N choose k always equals n choose n minus k, because if I'm saying how many subsets of size k are there from a set of size n, that's the same as specifying, right, I'm picking a subset of size k from a set of size n. That's the same as picking the rest, right? All the cards or objects I didn't pick, right? The n minus k remaining objects, I might as well have said, oh, how many ways are there to pick all the rest n minus k objects from a set of size n? Okay, so that's why these are equal. Of course, you could also use the formula and see it right away, right? That's the formula for n choose k, and for n choose n minus k, it's n factorial over n minus k factorial times n minus k, but that's just k factorial. So of course you see these two are equal. Okay, so either way, we get that those two are equal. Okay, you could have also just calculated it. This is making a big deal about a simple part. Could have just calculated it, but anyway, 4 choose 3, this is the way I think of it, is equal to 4 choose 1, and anything choose 1 is just that anything. So 4 choose 1 is just 4, so times 4, and then 4 choose 2, 4 factorial over 2 factorial times 4 minus 2 factorial. This down here is just 4. That cancels the 4 and 4 factorial. I'm left with 3 times 2, so that's 6. Okay, and that number happens to be 3,744 different hands. Okay, and that turns out to be 0.144%. Okay, so your probability of getting dealt a full house is just 0.144%. Okay, so it's still quite a rare hand. All right, next one is the flush. We've kind of already talked about this. And of course, this is excluding the royal flush and the straight flush. Okay, we already dealt with those. So these are hands that are, at best, called a flush, nothing better. Okay, and this is just 5 cards of the same suit. Okay, so how do we count this? Well, let's again think about values and suits, right? So I need 5 cards of the same suit. Okay. So if they're all going to be of the same suit, can they ever have the same value? Well, no, because if they had the same value and the same suit, they're the same card. Okay, so if I think about counting the values, the possible values I could have in my hand here, it's really just the same as saying I need a subset of 5 values out of the 13 total values, right? Because I can never have a duplicate value that's also in the same suit. That would be a duplicate card. Okay, so to specify the values in a flush, you're necessarily specifying a subset of 5 cards, right, from the set of 13 values, a subset of 5 values from the set of 13 total values. That's just 13 choose 5. Okay, and for any one of those, how many options do I have for the suit? Well, there are 4 options for the suit. So this is for the values, set of 5 values. And this is the suit. But counting it this way, this is counting all of the hands that are flushes. Okay, we want to have all of these hands we're counting be at best a flush. So they can't be a royal flush, they can't be a straight flush. How do we account for that? Well, this is all of the flushes. Let's just subtract off all the ones we already counted. So how many royal flushes were there? There were 4, and there were 36 straight flushes. So I'm just going to subtract off here 4 minus 36. This is royal flushes and straight flushes. So we don't want to count those. Okay, and all in all, what do we get? Well, this is, I can factor 4 out of everything. This is just 4 times 13 choose 5 minus 10. Okay, and it turns out that is 5,108. Okay, that many hands. And this turns out to be 0.197%. So that's your probability of getting a flush. Okay, 5 cards of the same suit. All right, next one is called a straight. What's a straight? It's just 5 sequential cards of any suit. We don't care about suit here. So it's kind of nice. Flushes, you only care about suit. They have to be the same suit. Straights, you only care about value. They have to be sequential in value. Okay, so this is excluding, of course, the royal flush, which is also a straight, and straight flush. Okay, 5 sequential cards. So how do we count this? Well, again, let's break it up into values and suits. Okay, values and suits. Okay, so I have my 5 cards here. I have my 5 cards here. And what are my options for the values? Well, how many different sets of 5 cards are there, okay, that have 5 sequential values? Well, we actually already listed them. We already listed them up here. Okay, there are 10 of them. Okay, but how else could you think about it? Well, if they have 5 different values, which they must because they're sequential, okay, so they're definitely going to have 5 different values, I can always arrange them in order like this, listed in a line. And I could think of it as, well, how many options are there for the first card? Well, if I'm going to have 5 sequential cards, we can go back up here. 5 sequential cards, the lowest value I could have is an ace, and the highest value I could have is a 10. Right? If my highest value is a jack, there aren't enough cards to make 5 in a row. So that's just 1, 2, 3, all the way up to 10. That's 10 different starting cards. So for my first card here, I have 10 options. And then for any such starting card, how many options do I have for the next card? Well, there's only one option. It has to be the next sequential card. They have to all be in order. And I only have one option for the next, one option for the next, one option for the next. So once the starting card is chosen, it could be ace all the way to 10, all the rest of the cards are determined. So there's only 10 options. Pretty much just an alternate way of counting this, not having to list them all out like this. Okay, it's just how many different locations can that sliding window lie in the list of all the card values. Okay, so that's how many values I have. And what about the suits for those cards? What about the suits for those cards? Well, do I really care about their suit? No, I don't care about their suit at all. There are 4 options for the suit for the first card, 4 for the second, 4 for the third, 4 for the fourth, and 4 for the fifth. I'm completely free to choose the suits, and I never have to worry about ever using up a suit for a future card because I know all of these values are different. Right? So I never have to worry about already having used a card up because all the values are different. Right? So there's no possible way the cards can be the same. Right? Whether their suits are the same or not, the values are different. So I'm never going to get in a situation where I want to include a card, but I've already used it. So I'm free to choose the suits however I want. Okay, free to choose them however I want. So how many possible options are there here? Well, it's just the product of all of these. 10 times 4 to the 5th. Okay, so this is all possible straights. Okay, number of all possible straights. But again, we want the hands that are at best straights. So they can't be a royal flush and can't be a straight flush. So what do? Same thing as before. We can just subtract that off. So 10 times 4 to the 5th, this is all the straights. Then we want to subtract off the royal flushes. I remember there were 4. And the straight flushes, there were 36. So this is royal flushes and straight flushes. Okay, so all in all, what do we get? It turns out we get 10,200 hands. Okay, so this is 0.393%. Still have not cracked 1%. Okay, but we're quite through the list of the categories. All right, let's just do a recap. All right, so we're up to straights now. So all of these categories have less than 1% chance of occurring. Okay, they're all quite rare. That means these must have a pretty high chance, some of them. So we'll see as we keep going. Just something to kind of keep in mind. All right, next one is 3 of a kind. Okay, so this is 3 cards of the same value. Okay, and of course we want to exclude the 4 of a kind, which sort of has a 3 of a kind as a subset, and the full house. Okay, so we want hands that are at best 3 of a kind, nothing better. All right, so we can picture our hand here. Okay, and we have our 3 cards that make up our 3 of a kind, right? So maybe it's like ace of diamonds, ace of hearts, ace of spades, something like that. Okay, then we have 2 cards left over. Okay, 2 cards left over. So let's try and count this. So let's start with counting this part. How many different value options do I have? Well, there are 13 different values, right? Ace through king. Any of those could be the value for my 3 of a kind. Okay, and what about for suits? Well, there are 4 total suits. I need 3 of them. So I just have to specify, I get a choice about which subset of 3 suits to use. These are my suits. These are my choices for my suits. Okay, and what about for these 2 other cards? Well, here's where we have to get into, maybe I'll even write this. This is excluding 4 of a kind and full house. Okay, so we want to exclude getting 4 of a kind, and we want to exclude getting a full house. Okay, so in particular, could I have another ace here? Well, it would have to be the ace of clubs, but no, because then this hand would actually be 4 of a kind. I don't want that. So I can't have another ace. Okay, and the other thing we have to worry about is we can't have a full house. So I can't have 2 of the same value card here, because otherwise that would be a full house. Okay, so what are my possible choices for the values of these 2 locations here to avoid those other 2 hands? Well, I can't choose an ace. Okay, so I'm kind of down to a set of 12 values I could choose from, and I also want those values to be different. Okay, so in other words, I want a subset of size 2 of that set of 12 remaining values. So that's just 12 choose 2. Okay, this is picking 2 distinct other values. Right? They can't be the ace, they can't be the value for my 3 of a kind, and they can't be the same value, or else that'd be a full house. And now what about choices for my suits for those other 2 cards? Well, there's no chance of running into any other hand as long as these 2 value cards are different, so I'm free to choose the suits however I want. So I have 4 choices for the suit of one card and 4 choices for the suit of the other. Doesn't matter. Suits for other 2 cards. Because I know their values are different because I'm picking a subset, so I don't have to worry about having the same card listed twice. The values are different, so I'm free to choose 4 suits, any of the 4 suits for each of the cards. And all in all, if you do all of that multiplication, you get 54,912 hands. And finally, we have broken 1%. This is 2.11% of all hands. Okay, so your probability of getting dealt a 3 of a kind is about 2%. All right, next one is 2 pair. Okay, so this is 2 sets of 2 cards of the same value. Okay, so I have a picture of my hand here. Maybe I have, ace of diamonds, ace of hearts. Right, maybe that's 1 pair. And maybe over here, maybe I have queen of spades and queen of clubs. Right, maybe that's another pair. And then I have an extra card. Okay, so are there any hands we want to try to avoid that we already counted? Well, yeah, we have to try to avoid the full house. Okay, because if this card is an ace or a queen in this example, we would have 3 cards of one value, 2 cards of another. Okay, and that would be a full house. So we want to exclude full house. Okay, so we'll keep that in mind. All right, so, and also these 2 sets of 2 cards of the same value, they have to have different values, right? Because if they had the same value, that'd be 4 of a kind. Okay, so maybe I'll exclude full house and 4 of a kind. I'll just make that note just so we remember. Okay, so we don't want these 2 pairs to actually have the same value. We want them at different values, or else that'd be 4 of a kind. And also, we don't want this other card to have one of the values we already picked for our pairs, because that would be a full house. Okay, so if I'm thinking about the possible values for these, let's just focus on the 2 pair part first. We'll deal with this last card at the end. If I'm just focusing on which values I could have here, I can't have the same value. They have to be different values, so I want a subset of size 2 of the 13 values. So that's 13, choose 2. Those are my choices for the values of these 2 pair. And what about the suits? Well, now that the values are different, I'm free to choose any 2 out of the 4 suits for the first value. So that's 4, choose 2. Okay. Any subset of 2 from the set of 4 suits I can apply to that pair. And then over here, I can take any other subset, or the same subset of suits if I want. The point is I'm free to choose, again, any 2 out of the 4 suits for that pair. Okay, so these are the suits, and all of this is counting for the 2 pair. But now we have to deal with that last card. Okay, so how many options are there for this last card? Well, it can be any card, like we said, as long as we don't make a full house. So in other words, as long as we don't choose one of these 2 values. Okay, so there are 52 total cards. I have to avoid 4 values from this value I chose over here. I have to avoid all the aces. Can't be the ace of diamonds, hearts, clubs, or spades. So there are 4 values I have to avoid there, and another 4 I have to avoid there, because the 2 values of these 2 pair are different, because otherwise it'd be 4 of a kind. Okay, so out of the 52 cards, right, I can't have any of I can't have this value of my first pair of any suit, that's -4, that I can't choose. And again, from here, I can't have that value of any suit, that's minus another 4. So all in all, I can't choose any of the 52 cards. I can choose any of the 52 minus the 8 I just took off cards. So this is other cards of different values, right, to avoid a full house. Okay, so if you do all that multiplication, you get 123,552 hands. And that is 4.75%. So still not that high, even down to 2 pair. Okay, there's only two more categories. Okay, there's only 2 more categories, so these are going to take up a large percentage. These are going to be much more common. So one of them is 1 pair. Okay, so this is 1 set of 2 cards of the same value. And I'm not going to write everything this excludes. Obviously, this excludes 2 pair, excludes 3 of a kind, 4 of a kind, excludes full house. There's too much. Okay, so anyway, we know it has to exclude everything else. It has to be 1 pair at best. So maybe this is my pair, maybe ace of diamonds, ace of hearts. And then I have 3 other cards that I can choose as long as I don't make a better hand out of it. Okay, so let's focus on the 1 pair first. So there are 13 different values that it could be. And what about my suit choice? So this is my value. My suit choice, again, I can choose any subset of 2 of the 4 suits. That's 4 choose 2. These are my suits. And this is for my 1 pair. And what about the other 3 cards? What about the other 3 cards? Okay, well, I can't have an ace anywhere. I can't have the same value in my pair anywhere, or else I get at least the 3 of a kind. So I don't want that. So there's only 12 possible values I can choose from. Okay, and could any of those values I choose from, or for these 3 cards, could I ever have the same value appear? No, because if 2 values appear, then that'd be 2 pair. And if all 3 are the same value, that'd be a full house. Okay, so in other words, I can't have any repeating values among these other 3. And I also can't have the value I chose for my pair. So that's 12 remaining values, and I need a subset of size 3. I can't have any repeats. So that's 12 choose 3 choices for the other values. And this is going to be for the other 3 cards. Okay, avoiding everything we need to avoid. Okay, and what about the suits? Well, the suits, again, I'm free. As long as the values are different, there's no chance having the suits be somehow fall into, there's no chance that I could assign the suits in a way to fall into another category. In particular, I can't get a flush because I have a pair here. So those 2 cards are definitely different suits. So I can't possibly have 5 cards of the same suit. So I'm completely free to choose the suits of these other cards because I know their values are different. So that's just 4 choices of suit for each of the 3 cards. So that's 4 cubed. 4 times 4 times 4. And we get 1,098,240 hands. And we jump from 4% for 2 pair all the way up to 42.3% for getting 1 pair. So 1 pair is like about 10 times, maybe a little less, a little less than 10 times more likely than getting 2 pair. Okay, so this is quite common. Okay, so if you're ever playing this game, there's a decent chance if you're playing with some people, there's a decent chance someone got 1 pair. Okay, at least 1 pair. Pretty common. And the last one is no pair, or sometimes called high card, because that's what you use to determine who wins in this case. And this is just all the stuff that does not fall. I'll just say all hands that don't fall into any previous category. Okay, so this is just all the rest. Okay, so if I have my hand here, I have these 5 cards. Okay, and they can't all be the same suit. They can't be in sequential order, right? I can't have a pair anywhere. Okay, there's a lot of stuff to try to avoid. Okay, so how can we try and count it other than just saying, oh, it's 52 choose 5 minus everything else? Okay, we can actually count it in a better way. Okay, well, let's focus on the values first. So remember, I can't have any repetitions in my values, or else I have at least a pair. Can't have any repetitions. So out of the 13 values, I need to pick a subset of size 5. All of the different values have to be distinct. Okay, so that's 13 values choose 5, but I have to avoid choosing a subset where they can be listed in sequential order. Okay, so how many ways were there to do that? You might remember, but we listed them all out here. There were 9 here plus 1, that's 10. I think we counted somewhere else too. Yeah, right here. Okay, so there are 10 possibilities for getting 5 sequential cards. We counted it when we were counting straights. So we have to get rid of those. So we don't want to have any of the subsets that can be ordered sequentially for our values. Okay, so these are values for straights. We want to avoid that. Okay, and what about the suits times all of our choices for the suits? Well, I can pick the suits completely freely, except I want to avoid flushes. Okay, so how many choices for suits of these cards are there that would make it a flush? Well, just 4, right? Because they either all have to be hearts, all spades, all clubs, or all diamonds. Okay, besides those 4 options for suits where they're all the same suit, I'm free to choose the suits however I want. So that's 4 to the 5th, 4 options for each card, minus the 4 suits I want to avoid, suit choices for flushes. I want to avoid all those. Okay, and this is it. So that's how many hands don't fall into any of the above categories. And it turns out you get 1,302,540 hands. And it turns out that is 50.1%. Okay, so you have you have higher than 50% chance of getting nothing actually playing this game, which is kind of funny. Okay, all of the other categories together add up to less chance than getting nothing, because it would be 49.9 something. Okay, and by the way, all these percentages have been approximate. It's just to like 3 significant digits or something. Okay, but yeah, so you have a better than 50% chance of getting nothing, no special category, and all the other categories add up to just under 50%. Okay, so maybe you'll remember this the next time you decide to play this version of poker with anybody. And as you go back through, you can see that starting from the bottom here, we go from the largest number of hands, and it slowly decreases, or sometimes rapidly decreases, until we get all the way up to the royal flush, where there's only 4. Okay, so that's how this ranking was developed. It's just ranked in terms of increasing probability. So the rarest hands are the highest ranking in poker. Okay, so hopefully that was a fun video and provided some examples if you're new to counting that can help you better understand everything. Okay, so thanks for watching. I'll see you in the next one.